Okay, this is Module 2 Homework 1 notes, and we're going to be talking about graphing equations. So the first thing that we're going to look at is a coordinate system. That's going to be what this graph is called. That's a coordinate system. And so we are going to label the quadrants. So our quadrants are going to start in the top right corner with quadrant 1, and we're going to go counterclockwise. That's going to be quadrant 2, quadrant 3, and quadrant 4. So we've labeled the quadrants. Then we're going to look at the x-axis, which you'll see this little x here. That tells us the x-axis, and you'll see x tells you how far left or right you're going to go. So the x-axis always runs horizontal, left and right. Then we're going to look at the y-axis. Our y-axis is going to run up and down. That's our little y here. And the y-axis is always vertical. And it's going to tell us how far up or down we go. That's always going to happen on the y-axis. And then we have the origin, which the origin is going to be the center. And that's always going to be the point 0, 0. So an ordered pair, x is always listed first and y is always listed second. So when we look at the next example, it asks us to plot these points. So when we're plotting these points, our x-axis is going to run left and right. Our y-axis is going to run up and down. And if we look up here, x always tells us how far left we go. Left is going to be a negative number, right is going to be a positive number, and then y tells us how far down for negative or up for positive. So we're going to use those rules when we plot these points. So our first point is going to be 4, negative 1. So that tells us that the x is 4 and the y is negative 1. So that means we would go over to 4 on the x-axis, and then we're going to go down to negative 1 on the y-axis. So it's kind of like we're drawing a line through our x value, a line through our y value, and where those two lines intersect is where that point's going to fall. This is like the address, okay? So if you're talking about two streets intersecting, 4 and negative 1 intersect right here. So that's our first point. Then we have the point 1, 2. So x equals 1 and y equals 2. So if we find 1 on our x-axis, if we were to draw an imaginary line there, and then we find 2 on our y-axis, we draw a line there, and where those two intersect is going to be our point. So we have a point at 1, positive 2. We always give the x value first and the y value second. And then our last point is going to be negative 2, 4. So x equals negative 2 and y equals 4. So same thing, we're going to find negative 2 on the x-axis. It's like having an imaginary line there. We've got 4 on the y-axis. We draw that line. And where these intersect is going to be our point. So we have negative 2, 4. We've gone through negative 2 on the x, and we're at 4 on the y. So we do have a note here at the bottom that says always check the scale. Sometimes when we label our x and y, this is counting by ones, negative 1, negative 2, negative 3, or we do 1, 2, 3, 4. Sometimes the scale is going to be different. So this could be a 2, 4, a 6, an 8. So you need to watch and make sure you're not counting by 2s or counting by 5s, because sometimes your graphs on your homework are not going to be counting by 1. So you need to watch that. So the next one says, is the equation linear? So the definition of a linear equation in two variables, that means we have an x and a y, two variables. It's an equation that can be written as ax plus by equals c, where a, b, and c are real numbers, not fractions, and a and b are not both 0. So if a equals 0, then b cannot be 0. Or if b equals 0, then a cannot be 0. So that's called standard form of a line, ax plus by equals c. So a cannot be 0 if b is, and b cannot be 0 if a is, and they cannot be fractions, okay? So the first example says, is the equation linear? So if the equation is linear, we could write it in standard form, ax plus by equals c. Here we have a equals 10, b equals 10, and c equals negative 10. So this first one, part A, is written in standard form. We don't have any fractions. This is going to be a linear equation in standard form. So the answer here is yes, this is linear. Then part B, we have this odd part, right? This absolute value bar. That makes this not linear. So anytime we have something that's like different or odd, most of the time that's not going to be a linear equation. So the next one, we have this y to the third power. That makes this not a linear equation. And here we've got x in the bottom of the fraction, y in the bottom of the fraction, so that is not a linear equation either. Now, just to go over it, you could have a linear equation written in slope-intercept form, y equals mx plus b. That means your equation could look like this. This is different from standard form, so we are allowed to have fractions here, but we've got y to the first, x to the first. We don't have anything weird in the bottom of our denominator, so no x in the bottom or y in the bottom. We don't have any unusual exponents, 2's or 3's, so the answer, this one, would also be a linear equation, okay? So looking at the next one, we are asked to graph an equation. So the first way that we're going to learn how to graph is by creating a table of values. So we're going to take this and we're going to, you can see right here, that little negative is supposed to be with that 10. So you might want to rewrite that. We're plugging in negative 10. So we're going to take y equals x over 5 minus 2, and we're going to put this negative 10 where this x is. We're saying x is negative 10. So we get y equals negative 10 over 5 minus 2, which simplifies to be negative 2 minus 2, which is negative 4. So now we have found the point. X was negative 10, and we got y is negative 4. So that's our first point. So we're going to find negative 10 all the way down here to the left on the x-axis. We're going to find negative 4 on the y-axis, and where those two intersect is going to be the point that we need. So we get negative 10, negative 4. So that's our first point. All right, so now we're going to plug in x equals 0. So we've got y equals x over 5 minus 2. We're going to take that 0 and we're going to put it in for that x value. So we get y equals 0 over 5 minus 2, which gives us 0 minus 2, which is negative 2. So now we have the point 0, negative 2. So for us to graph that, we're going to find 0 on our x. So we're not going left or right at all. So here's our x value. We're going to find negative 2 on our y. So that would be our y value. And our intersection is going to be right here on the x-axis. Nope, on the y-axis. Our x-axis runs left and right. Our y-axis runs up and down. So that point is going to be on the y-axis at the value of negative 2. This 0 tells us we're not going left and we're not going right. So we're going to stay right on this y-axis. Give me just a second. Okay, so then the last point, we are going to take this 5 and we're going to plug it in for that x. So we get y equals 5 over 5 minus 2, which gives us 1 minus 2, which equals negative 1. So now we have the point x was 5 and y was negative 1. We're going to go over to 5 on the y-axis, 1, 2, 3, 4, 5, and go down to negative 1, and that is going to be our point. So now you see we've got a straight line here. Passing through those 3 points. Now, a lot of people ask, well, how did we know to plug in negative 10 and 0 and 5? So for this particular question, we had 5 in our denominator. Negative 10 is divisible by that 5. 0 divided by 5 is 0. And 5 divided by 5 gives us 1. So that eliminates having to work with fractions. So if we had a problem that was x over 3, then we might want to plug in things that are divisible by 3. So we could plug in a 3 here, we could plug in a 0, we could plug in a negative 6, and then we wouldn't have to deal with fractions for that one either. So the next one says, for the given graph, what is the value of y when x is 4? So we are first going to find x4 on the x-axis. Then we're going to draw a straight line up or down that intersects the graph, which is the diagonal line. So if we draw a line up and down through that, that shows us that we have an intersection point. So then at this intersection point, we're going to slide over to the y-axis, and that's going to show us our y value. So when x equals 4, we get y equals negative 5. If we had another question that said, when y equals 1, what is x? We would do the same thing but opposite. We would find 1 on the y-axis, so we've got 1 on the y-axis, we would draw our line to intersect with our graph, and then we would slide down to our x value, and we would find when y equals 1, x equals -2. So both of these could be written in an ordered pair. The x is first, the y is second. So we would get 4, -5, and this one would be -2, +1. We always want the x first and the y second. So the next example asks us to complete the table and then use the appropriate tool to graph the equation. So when we look at this equation, we should notice that we have this x squared here. That tells us that this is not linear. Okay, so it's not going to be a straight line. So anytime we see x squared, the graph is either going to be a u or an upside down u. It's called a parabola. So we're going to make the table the same way. We've got y equals x squared minus 5. So we're going to take that -1 and we're going to plug it in for that x squared. So we get x squared, and we're putting a -1 in where that x was. Now, -1 squared is +1. So we end up with 1 minus 5, which is -4. So that gives us our first point, which is going to be -1, -4. So we're going to go to -1 on the x and then down to -1, -2, -3, -4 on the y. Then we're going to do it again. This time we are plugging in 0 for x. So we get 0 minus 5, which is -5. So now we have the point 0, -5. So that means we're not going left or right at all because our x is 0. So we're just going to stay on that x-axis, and we're going to go all the way down to -5, and we're going to draw our point. And then the last one, we are plugging in 1 for x. So we get x squared minus 5. This time we're plugging in 1. 1 squared is 1, and we get 1 minus 5 is -4. So that gives us the point 1, -4. So we're going to go over to 1 on our x and down 1, 2, 3, 4. So since we know the general shape of this graph is going to be a U-shaped graph, you can see that that's what's happening with our graph here. So we're going to connect those dots, and we're going to connect them in a U shape. So the next one, again, we've got this absolute value bar that tells us that this is not linear. Anytime we have absolute value, which are these bars, then that tells us that our graph is going to be a V-shaped graph. and that's from the absolute value of x. So we're still going to complete the table. We get y equals -5 times the absolute value of x, and we are this time plugging in -1 for our x, so we get -5 times the absolute value of -1. Now, if you don't remember what absolute value means, we're going to tell how far away from 0 is this number. So if we were looking at a number line and we had 0 in the middle, we would say, okay, how many spaces away from 0 is -1? So we would count 1 space. So that's going to make that positive. So anytime you see an absolute value bar, you're going to take the positive of the number that's inside that bar. So this becomes -5 times +1, which is -5. So our first point is -1, -5. We're going to go over to -1, down 1, 2, 3, 4, 5, and we went down because our negative numbers go down on the y-axis. So we get our first point. Then we're going to do the same thing with 0. We've got y equals -5 times x. We're plugging this 0 in here. And the absolute value of 0 is 0. So we get -5 times 0, which is 0. So our second point is going to be 0, 0. That is our origin. And then our third point, we get y equals -5 times the absolute value of x, and this time x is 1. So the absolute value of 1 is just going to be 1 because 1 is 1 space away from 0. So we end up with -5 times 1, which is -5. So we get the point 1, -5. So that means we're going to go over to 1 and down 1, 2, 3, 4, 5. And you can see that the shape of this graph is looking like it will make the V that we need. Don't make the mistake of curving it and making it a U. It's not a parabola. So anytime you have these absolute value bars, your graph is a V or an upside down V. So when we connect these, we are going to make it an upside down V. And that's the last question from Module 2, Homework 1.